Hello guys, welcome to today's discussion. So in today's discussion, we're going to look at the implicit method of differentiation and how we use it, how and when do we use it. So if you have a function of x and y, then dy dx is given by negative of the partial derivative of the same function with respect to x divided by the partial derivative of the same function with respect to y. So that's how we are going to get dy dx. So this is how we are going to differentiate it by the implicit method of differentiation. So let us look at what we have on the board here. Here we have x cubed plus 2y cubed, which is equals to 3xy. So we can see to say that this function is a function of both x and y. And then how would we find it, or how would we differentiate it? So differentiating it, we are first of all going to find its partial derivatives, the partial derivative with respect to x and also the partial derivative with respect to y. So for a start, I'm going to find the partial derivative of x of this function. Now the partial derivative of x, we know to say that we are only interested where we can see x is. So this side you're going to have 3x squared, and then this one we can also bring it this side of the equation so that it becomes a negative, and then differentiating this one with respect to x, we're only going to remain with 3y like that. And also finding the partial derivative of this function with respect to y. Now with respect to y, we're going to say we're only going to focus where there is a y, so we ignore this one. So differentiating this one, this gives us 6y squared, and then we're going to treat this one by bringing it this side where it becomes a negative, and also we get that. And then this implies that dy dx, which is given by the negative partial derivative of x divided by partial derivative of y, is equal to. So now what is the partial derivative of this function with respect to x? It is this one. So we are going to say negative of that, which is 3x squared minus 3y divided by the partial derivative of y of this function is actually 6y squared minus 3x like that. And then from here you can either distribute this negative into there and see what you get, if it can be simplified any further. So distributing the negative there, you're going to have negative 3x squared plus 3y divided by 6y squared minus 3x. So this is your derivative. But then just for this question, this answer can be simplified by actually factoring out what factoring out 3, and what we remain with is y minus x squared like that. And also the denominator can be factored that we have a 3 here, also have a 3 in this 6. So you can say we have a 3, so that we remain with 2y squared minus x like that. And then this and that will go such that our final answer will be of this nature. So this is what you get by differentiating this function by implicit method of differentiation. So here is another example of a function of both x and y. Then we have to differentiate this function. So differentiating this function, the method that is applicable here is the method of implicit method, because we know to say implicit method is a method that is used to differentiate functions of multivariables x and y like that. So for this one, we first of all start with finding the partial derivatives, which is that one with respect to x and the other one with respect to y. So the partial derivative of this function with respect to x is 2x like that. Everywhere else we ignore because we do not have an x, so we treat everywhere else as constants. And then the partial derivative now of the same function with respect to y, it is equals to 1 because we know what you get when you differentiate y there. So from here we can then say that dy dx, which is given by the negative partial derivative of this function with respect to x, is divided by the partial derivative of the same function with respect to y. So this is actually equal to negative of, what is the partial derivative of this function with respect to x? It is 2x divided by the partial derivative of this function with respect to y, which is just a 1 like that. So from here we get 2x as our final answer for differentiating this function. Okay, let us look at another example that is slightly different, but then still using the same method. Alright, so here's another example that demands the use of implicit method to differentiate it. So this function here, already you can see it's the function of x and y. So differentiating this one, we use the implicit method, of which we by now understand what is there. So we'll start by finding the partial derivative of this function with respect to x, which is 1, and also the partial derivative of the same function now with respect to y. So we have a natural log here of y. So the natural log of y, differentiating this one, we know what we get. We'll get 1 over y like that. And then from here, we can then apply the formula for implicit method. So the formula says this: the negative for the partial derivative of y divided by the partial derivative of the partial derivative of x divided by the partial derivative of y, like that. So then we know what this is. So this is negative 1 divided by 1 over y. So we can simplify what we have here. Nicely, know it's to say we have negative 1 divided by 1 over y, of which this is just negative 1 times y, like that. So our final answer is negative y. So I think this is the last question that we can look at. So in conclusion, all in all, for differentiating functions using implicit method, you're going to find functions of multivariables. It could be x and y like that in the same function. So first of all, you need to take the partials with respect to x and respect to y. Then you can use this formula. That's the only way that you're going to find the solutions. Wait.